Hello, my friends. Today we're talking about multiplication and division in scientific notation. The first thing we're going to do is I'm going to set up two problems and we're going to solve them simultaneously. The first one is 7.50 times 10 to the 6th divided by 3.781 times 10 to the 4th. The next one is 1.23 times 10 to the negative 2 meters multiplied by 5.0 times 10 to the 1 meters. These look tricky, but they're actually very simple to solve. So step one, know your signs for division. It could look like a division sign, it could look like a slash, or we could put it over into a fraction. No matter which way they're put, you're still going to follow the steps for division in scientific notation. So the first step is to complete the operation, either multiplication or division, before your x times 10 to the. So for this first one, we're going to divide 7.5 divided by 3.781. On this side, we're multiplying 1.23 by 5. So we end up with 1.9836 for this one. And for this side, we're ending up with 6.15. The next set is to do for multiplication, you're going to add the exponents. And for division, you're going to subtract the exponents. So for the initial setup, for the multiplication, minus 2 plus 1 is negative 1. 6 minus 4 is 2. Then you're going to put it all together. So on this side, we have 1.9836 times 2. And on this side, we have 6.15 times 10 to the negative 1. And don't forget to multiply your units so we end up with meters squared. Then you're going to put it in proper scientific notation. That's 1.9836 times 10 to the second, or 6.15 times 10 to the negative 1 meters, because you're putting it all together. And putting in proper scientific notation, because sometimes you might end up with bigger numbers, you have to convert it back to proper scientific notation, and then you always have to follow rounding rules to put the answer into the correct number of sig figs. So we end up with 1.98 because 2 sig figs after the decimal for, 3 total sig figs, and this was 2 total sig figs. Okay. This probably was a lot of information, so let's do some examples. So example 1. 6 times 10 to the negative 5th multiplied by 4 times 10 to the negative 2nd. So remember, we're going to do this side first. So 6 times 4 is 24. Then we're going to, write the start of your scientific notation, and then for multiplication, we're adding. So negative 5 plus negative 2 is negative 7. Then you have to count sig figs for rounding. And remember, for multiplication and division, it is the least amount of total sig figs. So that is 1. So we have to round to 1 sig fig, which would be, so you remember you underline your sig fig and then you look to the right. So that would be under 5, so I just would be 2. So this would be 2. Sorry, color coding. 2 will actually be 20, but remember, I got to move it 1 to the left. So when you're moving it 1 to the left, you have to subtract 1 from up here. So it's 2 times 10 to the negative 6th. And that is your final answer. 2 times 10 to the negative 6th. Let's try a division one. 7.8 times 10 to the 4th divided by 7.8 times 10 to the fifth. Remember, you do everything on the left first. So 7.8 divided by 7.8 is 1. Times, because you're going to set up your scientific notation, 4 minus 5 is negative 1. Then we count our sig figs for rounding. And remember, it's the least. They each have 2. So on our final answer, that's already in proper scientific notation, we need to represent 2 sig figs. So that means we have to do 1.0, because remember, ending zeros after a decimal are significant, times 10 to the negative 1. Okay, let's try another one. 4 times 10 to the fifth times 4 times 10 to the fifth. So 4 times 4, doing everything before the x first, is 16. Then we're going to set up our scientific notation, and 5 plus 5 is 10. Now, we've got to worry about sig figs for rounding. And remember, with multiplication and division, it's always the least number of sig figs. Well, there's only 1 in either of them, so that's what we're rounding to. So we underline that first sig fig and look over, and look, that's 5 or larger, so we round. So at 16, in order to put it, we have to move it 1, so that becomes an 11. So it becomes 2 times 10 to the 11th, and you don't add anything after the decimal because you want to make sure that you're representing proper amount of sig figs. Okay, my friends, let's try another example. Remember, it's multiplication. 7 times 10 to the 9th times 10 times 10 to the 6th. So for multiplication, we do this first. So 7 times 10 is 70. And we're going to set up the scientific notation, and we're going to add 9 plus 6 is 15. Now, remember, we have to figure out sig figs for rounding, which is the least amount of sig figs, which is 1. And lucky for us, our answer only has 1 sig fig, so we're going to leave the 7 alone. But remember, we also have to put it into proper scientific notation, which means we've got to move the decimal 1 over here, so we're adding 1 up there. So it's 7 times 10 to the 16th is your final answer. Okay. Let's try just 2 more examples. Because we haven't done that many for division. So let's do 7 times 10 to the 11th divided by 2 times 10 to the 6th. 7 divided by 2 is 3.5. Times, and we got to remember, we got to set up your, and it's going to be 11 minus 6 is 5. So we have 3.5 times 10 to the 5th. So, but let's remember, we got to count our sig figs for rounding. So, remember, it's the least, so 7 and 2 each have 1 sig fig. So we have to round to 1 sig fig. So we're going to underline that first sig fig and then look to the right. That's 5 or above, so that becomes 4. So our final answer is 4 times 10 to the 5th. And let's do a last example. 2.4 times 10 to 100 divided by 1.2 times 10 to the 90th. So first all, you do the stuff before the x. So 2.4 divided by 1.2 is 2. Then we're going to set up the stuff after the x. 100 minus 90 is 10. Okay, now remember we got to do sig figs for rounding. And remember, you have to count the least. So 2.4 has 2 sig figs, 1.2 has 2 sig figs. So we have to round to 2 sig figs. Keep in mind that this isn't proper scientific notation, but we have to represent 2 sig figs. So you have to add an ending 0. So 2.0, because remember ending zeros after decimal represent a significant figure that we were not able to represent through rounding, times 10 to the 10. And that is that answer. Now it is time for you to try some problem solvers. Okay, let's look at problem solver 1. We have 2.29 times 10 to the 6th times 7.26 times 10 to the 5th. Okay, now it's your turn to try. Okay, the first thing we do is the stuff before the decimal, which ends up with 16.6254, and then we add the exponents, because it's multiplication, times 10 to the 11th. Then we figure out our sig figs for rounding, which is 3. So we're rounding at this 6, so we leave it alone. Then we put it in scientific notation for a final answer of 1.66 times 10 to the 12th. Okay, time for problem solver 2. Solve 6 times 10 to the 6th divided by 7.5 times 10 to the 3rd. Okay, the first thing you do is solve everything before the x. So 6 divided by 7.5 is 0.8. Then 6 minus 3 is 3. We figure out our sig figs for rounding, which is 1, and we already have 1 shown. And then we put it into proper scientific notation, which is 8 times 10 to the 2nd. Thank you for learning about operations in scientific notation.